All right, here's some problem solving for you. So you have a square and it's been cut into 3 sections. Question is each part 1/3 of the square? So when we're looking at 1/3, remember the denominator. We've got to evaluate this. The denominator is 3. I see 1, 2, 3. We're good, right? Everybody go, bam. Because it's not just a matter of how many pieces. They've got to be 3 equal pieces. Are these equal? Not all 3 of them are. These 2 are, but this one sure isn't. So you would answer in saying, these parts are not the same size, so therefore they do not represent 1/3 of the square. All right, number 1, you probably scratched your head on this. Maybe you thought of it, you figured it out. If not, please don't be too discouraged. Let's look at this together. It says that Mary, I'm looking here at number 1 on page 237. It says that Mary says that 1/4 of a pizza is always the same as 2/8 of a pizza. Now, Phil says that, while they are equivalent fractions, 1/4 and 2/8 are equivalent to each other, 1/4 and 2/8 of a pizza could represent different amounts. Who's correct? Oh. Well, if you said Phil was correct, he's the guy. And here's why. So I'm going to draw 2 round pizzas. 1, 2. Okay. Pizzas are about the same size. Okay. Let's pretend they're perfectly, identically the same size. The first one, we're going to cut into 4ths. 1, 2. Okay. So I have 1, 2, 3, 4. And I'm going to shade in 1/4, or 1 out of 4, right? Good enough. Now let's go over to the second pizza and let's cut this one into 1/8. So I'm going to cut this first into 4ths, and then I'm going to cut each one of these in half to have 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade in 2/8. Should have wrote 1/4 over here. Okay, here's 1/8, and here's 2/8. Hey, you know what? These certainly look like they're taking up the same amount of pizza. It's just that the 2/8, while they're 2 pieces, these pieces are smaller, but if you put those 2 pieces together, they take up the same amount of spots. I could even go back over here and prove it to you on this side by cutting these into 1/8 now. So I'll cut this in half, and I'll cut that in half, and bingo, same thing. So in this instance, 1/4 does equal the same amount of pizza as 2/8. But the thing that Phil was saying was that not always, and here's how it could not always be. Hey guys, when you go to a pizza parlor, do they only offer you one size of pizza? Or do they have 2, 3, 4 different sizes? This is where it could all go wrong, okay? Let's say one pizza you got was a small pizza. Okay, we'll do that, small pizza. And that was cut into 4ths. Okay, here's your 4th. And let's say Phil said, you know what, I'm real hungry. I want one of those family-size pizzas. I'm going to buy me a big old pizza. And I want that cut into 8 slices. Eighths. And he's going to eat 2/8. It's still a quarter of the pizza, but does this quarter equal these 2/8? I don't think so. This looks much smaller than this, right? So that was the tricky part. In order for fractions to be equivalent, we've got to have the same size whole. The same size candy bar, the same size pizza. You have to be comparing two identical things. Then you can divide them up and you'll have 1/4 equals 2/8. But if the two wholes that you're comparing are not the same size, then these fractions will not be equivalent because you're not dealing with the same size. All right, guys, you made it. You're on the final one. And I've got something for you here because number 2 says, Kyle says you can have an unlimited number of equivalent fractions to any given fraction. Is he right? Well, I tell you what, he is right, but I'm not going to go into it. My brain just exploded, and I'm sure yours has too. So we're not going to worry about number 2. You're done.